Well, it's been a little while since Tesla unveiled the Cybercab and much longer since they detailed their new modular manufacturing system, as they've called it, the Unboxed manufacturing system. Today I'm going to refresh your memory. Watch the original presentation of Tesla's massive innovation in terms of automotive manufacturing, which, in short, will allow Tesla to produce the Cybercab for an extremely low cost, very rapidly from a tiny factory footprint, meaning these things will ramp to volume production faster and cheaper than anyone expects, except maybe Tesla themselves. Remember, Tesla's publicly stated goal is first Robotaxis operating in Austin June this year. And roughly 12 months later, Cybercabs will be ramping up production in a massive way. Everyone seems to have forgotten this incredible presentation. So, over to Lars in France.
And when you watch it happen, it's actually really silly to a guy like me. You take all these stamp panels, you put them together, then you put them in a framing station, you build a body that looks something like a car, you put the doors on, and then you paint them. Once you get the color, you take the doors off, and then you start putting the interior inside the car. It comes in through the openings that already exist. I wish it went in like this big piece like this, but there's actually people coming in and out of the car. There's awkward, movements. Then we lift the car up, we put stuff from underneath it, we put it down, then we put the seats in the car, and finally we close it all out with glass and we bring those doors that went away for a trip and we put them back in the car. Most of the time, we're doing this with a big giant car and moving it and doing really nothing to it at all.
What's funny though in this whole process is that
That was super awkward. For those who don't know, this is the Model Y, right? Tesla just roasting their own manufacturing system. And it took a few years after Model Y was launched before Toyota, truly the most inept, impotent, neutered, brain-dead automotive manufacturer on the planet, bar none, no question. They're doomed. You understand, right? They're toast. And it's their own damn fault. It took a few years before the engineers at Toyota even bothered to look inside a fucking Tesla Model Y. That's how dumb these fucks are. Now, maybe a little bit of an analogy might be useful here. Imagine if when you went to do your grocery shopping, assuming you don't pay to save time and get it all delivered. But imagine if you needed to, let's say you purchased 65 items on your shopping list. Imagine if instead of a centralized location to buy everything at once, you were to go to 65 different stores. That's basically comparable to what happens today when manufacturing a vehicle. There's a huge amount of waste and unnecessarily travel, doing things over and over and over. Tesla's unboxed manufacturing system will be to vehicle assembly and manufacturing what the centralized grocery store or in some parts of the world supermarket is, shopping for food and other items. A massive revolution with huge cost and time savings.
That was humbling, but at Tesla, it's not good enough. If we're going to scale the way we want to do, we have to rethink manufacturing again. As part of the master plan, we have to make another step change in cost. We started this on Model Y when we made these huge gigacastings, and we deleted hundreds of parts. We simplified assembly with the Model Y structural battery, where we decided the floor should be a part of the car. The battery is the floor. We put the seats and the interior on the battery, and we bring it up through a big open hole, and we assemble it. And this allowed us to do things in parallel, fully rethinking the process and reducing the final assembly line by about 10%. And we thought maybe we could do this other places.
Yeah, I mean, in a way, the constraints become part of the solution rather than a problem.
So when you think about what I'm trying to say, I really want to hammer this home. When you have a car that's about 5 meters long, and you have people working around it like we did in Model 3, and we change that to this process where we take different parts of the car, and we can do more at the same time, like we did with the Model Y structural battery pack. What you see here is us doing that on the front part of the vehicle, or the rear part of the vehicle. That means we can get more people working on the car, or robots, working on it at the same time. That means we have better operator density, less time doing nothing. I call that space-time efficiency.
Well, the TISM is strong in this presentation. A little bit nerdy, but worth digging a bit deeper here. This space-time efficiency improvement and operator density improvement is a massive deal. You'll also note they mentioned you can have more people and or robots. This is a perfect place for Tesla Optimus humanoid robots, right? Simple, boring, repetitive tasks. So good. This tells us a few things. Because there's less movement, less travel time, you can put together a vehicle faster. In addition, you can do so in a smaller factory footprint. Because of this higher operator density, Tesla can produce a vehicle faster and in a smaller factory, which means smaller factory footprints, smaller production lines, higher density output from the same factory footprint, nothing like the automotive industry's ever seen before. And the whole purpose of Cybercab is to massively scale very quickly and provide extremely affordable transport as a service to displace miles traveled today in internal combustion engine vehicles with miles traveled in the future in Tesla electric robotaxis. It's directly in line with their mission. A lot of people don't seem to appreciate this thing is designed to be able to be manufactured really fucking fast, really fucking affordably, and from a tiny factory footprint. Cybercab production ramp is going to come out of nowhere and stun.
Operator density, which means more work, less time walking back to the station, 30% improvement in space-time efficiency. And because we're not building it in and out of the car with those slow movements of those robots I showed you from production hell, when we go to automate it, it's going to be a lot easier. In the end, that will probably look something like this, where we balance parallel and series manufacturing in a way where we only do things that are necessary, with a much shorter final line, blocking a lot less of the entire rest of the factory, so we can optimize material flow using the best practices. And what that means, it's going to look something like this, where we build all the sides of the cars independently, we only paint what we need to, and then we assemble the parts of the car once and only once. We put them where they need to go. The interior is attached from a bottom-up or a top-down strategy, so there's more access for those robots and people. We aren't moving heavy objects around and doing nothing to it, and it means we're doing more work on the car more of the time. And then when we take all of these tested sub-assemblies and we put them together, we finally assemble the car only one time, putting the sides on with all of their parts to a front and rear that was already assembled, carrying the floor in with the seats, and finally boxing it out with the doors one time, just like Cybertruck. So in the end, you get the same car, but it's not going to be a Model Y.
Yeah, this is not. Yeah. This is a Model Y for illustration, not the next-gen vehicle.
And now we know exactly what that next-gen vehicle is, the Cybercab. Now, it sounds pretty, just ridiculous when you think about how a vehicle's put together today, that this is a revolutionary process. And why is it revolutionary? Because you do things once, you handle parts once, and then you put it together once. Hello? Kind of amazing the entire industry isn't already doing this. But it takes a company with balls and brains to be willing to take the risk of engineering a new manufacturing process. It takes a lot of brain cycles to figure something like this out and then to implement it. That's why no one else has done it yet. It took a few years before companies were copying Tesla's massive castings, the gigacastings. I wonder how long before they can start to copy Tesla's unboxed manufacturing system. And how many Cybercabs will be on roads by then? Now, also a quick side note. Tesla's already told us that some of the techniques they've developed for this manufacturing system, not all, but some, to lower costs, are going to be implemented on their next generation, more affordable vehicles, which are entering production in the first half of this year. By the way, it's already March of this year. So those are going to enter the market. And Tesla's already one of the only companies making any money selling electric vehicles, and the biggest profits by far. Most others lose money, and Tesla's about to debut a couple of new vehicles, at least two, that are meaningfully more affordable using techniques they've developed internally that they haven't unveiled yet. And this is a really simple illustration, but they haven't gone into detail of how they're getting it all done. In short, Tesla's already making more money selling electric vehicles than anyone else per vehicle, and their cost to produce electric vehicles, the next-gen vehicles, is going to drop meaningfully. And then companies who are already losing money selling electric vehicles are making like $3.12 per vehicle sold if they're lucky. We're going to have to try and reverse engineer Tesla's new manufacturing system to lower their costs, otherwise they're going to lose more money trying to compete with Tesla on cost. Rest in fucking peace.
But it's not going to be a Model Y.
Yeah, this is not. Yeah. This is a Model Y for illustration, not the next-gen vehicle.
In the end, what does that mean? To increase the scale and adoption of electric vehicles on the orders of magnitude that we just showed you, we have to make constraints part of the solution. It leads us to greater than 40% reduction in footprint, which means we can build factories faster, with less CapEx and more output per unit. Faster, less CapEx, more output per unit dollar.
In our next powertrain, so those silicon carbide transistors that I mentioned that are key component but expensive, we figured out a way to use 75% less without compromising the performance or the efficiency of the car.
So it's time to speculate a little bit. We know that not all of the manufacturing system itself is going to be implemented in Tesla's next-gen vehicles. It will obviously in the Cybercab. What about the next generation drive unit? It's a pretty damn good chance. So pay attention. Might give some clues as to some of the cost savings in Tesla's soon-to-be produced next-gen vehicles.
Our new powertrain is compatible with any battery chemistry. That will give us great flexibility in battery sourcing. If we want to make EVs more accessible to people, they have to be cheaper. We've reduced the drive unit cost to about $1,000, and we don't think any other automaker is even close to that number. Finally, the bigger a factory is, the longer it takes to build. If we can build the same number of cars from a smaller factory, we are going to be able to scale EV production faster. Our next powertrain factory is 50% smaller than the one that's behind me today, even though it has the same capacity. All of these improvements, I think, are going to be transformative for the adoption of EVs and our ability to scale them. There's one more thing that I want to highlight. So I talked about how we had reduced the amount of rare earth in our powertrains. And as the world transitions to clean energy, the demand for rare earth is really increasing dramatically. And not only is it going to be a little hard to meet that demand, but mining that rare earth, it has environmental and health risks. So we want to do even better than this. We have designed our next drive unit, which uses a permanent magnet motor, to not use any rare earth materials at all. So how does all this fit into the master plan? We can make lower cost products that are still efficient and compelling, and we can make them at scale.
So again, this is not the manufacturing system, but the next generation permanent magnet motor. No rare earths. Big cost savings. Plus, their higher efficiency, which is also important. We also heard moments ago more detail about the smaller factory footprint. I mentioned this stuff at the time and people didn't really seem to be getting it. But man, they were pretty explicit. Smaller factory means you can build the factory faster, means you can crank out vehicles faster. If in addition to a smaller factory footprint, the actual production system means you can produce the vehicles faster, it's a double whammy. People are not ready for how quickly Tesla's next-gen vehicles and the Cybercab are going to ramp.
Less of constrained commodities, silicon carbide, rare earths. We're going to build them all in compact and high-output factories that are easy for us to build quickly. We're going to make that easy to scale powertrains all the way up to the levels that Drew and Elon mentioned at the beginning. And this achievement, like all of the achievements that I mentioned today, it's only possible because of the incredible people on our powertrain teams. They are absolutely committed to the cause of sustainable energy, and that is why we can do what no other company can do. So next, I'd like to welcome my colleagues Pete Bannon and David Lau.
Good afternoon, everybody, and welcome to Texas. Pictured here is the low-voltage system of a Model S from 2012. This car was primarily designed with vendor-sourced controllers integrated by Tesla. There are over 300 low-voltage devices that encompass everything from the mundane, like the light in the glove box, to the complicated, like the infotainment computer, to the safety-critical, like the airbags, steer-by-wire, and brake-by-wire. The low-voltage harness is built from individual wires, cut to length, crimped, and inserted into connectors, a manual process that is tedious, error-prone, and doesn't scale well. Going forward, we want to reduce the size and complexity of the harness and enable automated manufacturing.
These wire harnesses introduce extraordinary complications, especially in the early stages of development and bring up of a vehicle, because when we're trying to bring up this entire system and we see that it's not working properly, we don't know whether it's a problem with the software, with the controller, the processor, any of the endpoints in this entanglement of wires. And so we have to go and debug everything all at once. And Pete's going to tell us about how we're going to make it better.
Wait, I remember how they make it better. By no longer having a clusterfuck.
So I'm going to talk briefly about a few things that we've changed over the years since the Model S. With the Model 3, Tesla started designing an increasing share of our controllers by merging controllers together, and we were able to simplify the design with a significant reduction in wire count and weight. Going from S to 3, we reduced the wire harness by 17 kilograms compared to Model S. And this is a pretty big deal. And just to put that into context, our VP of Engineering, Lars, will deliver a bottle of your favorite spirit to your desk if you manage to save a kilogram of weight from the car. So this improvement cost him quite a lot. The original Model 3 controllers were enhanced and then built into Model Y. Those improved controllers were then moved back into Model 3 when we introduced the heat pump. At that point, we had shared controllers across both cars, which helped simplify our supply chain. Those Model 3 and Y controller designs were then updated and enhanced for the new versions of Model S and X that we introduced in 2021. For Cybertruck, we are now designing 85% of the controllers in the car. For the next-gen platform, we're going to finish the job and be designing 100% of the controllers to give us full control of the design and the supply chain at the component level. Having full control of the supply chain at the component level has been critical to Tesla over the last few years as the supply constraints have hampered our ability to build cars.
Yeah, just a reminder, the scamdemic, the futile, fascist, inhumane shutdowns, and then the shocks to global supply chains. Companies couldn't get parts. It was an absolute fucking nightmare. Tesla navigated this storm better than any other company producing vehicles by miles. Always best to control your own destiny. Next-gen vehicle, 100% of controllers, Tesla designed.
With that control comes control over all the software, which enables us to develop features and functionality that we never even dreamed of at the time we designed the hardware. So that's why you see software in your car is getting better and better over time in ways that we didn't even think of when we designed the hardware in the first place.
Yeah, Sentry Mode is one of my favorite last-minute changes.
One of my favorites.
With the introduction of Model 3 in 2017, we deleted relays and fuses from the car in favor of e-fuses. E-fuses replace moving parts with solid-state transistors. They provide fine-grained control of the power system to software and allow software to do advanced things like load shedding in the car under adverse conditions. E-fuses also allow for software-controlled retries for transient faults, and they all allow for detailed monitoring of the power system over time.
The theme you hear a lot about today is software-controlled hardware. And when I think about that in my team, software-controlled hardware is fundamentally about being able to sidestep what otherwise would have been static trade-offs between one attribute or another in a piece of hardware. We are able, with software, to instill intelligence, context awareness, and context-specific behavior into what otherwise would have been a piece of hardware that had to get optimized for one type of scenario. We get more of everything.
In 2022, we completed the transition from lead-acid batteries to lithium-ion batteries, and which use a new toolless connector. We expect lithium-ion batteries to last for the life of the car, so we don't expect anyone to wake up to a dead battery ever again. This eliminates a major source of failures for our car. And the toolless connector makes it easier to service the car, and it also includes a software feature to allow validation that the connector has been properly installed at the end of a service event, which removes another source of failures in our cars. Obviously, the mass and volume savings are also significant, which is super helpful. At Tesla, we're always trying to improve every single component in the car, and a nice example of that is the 15-inch display that was originally shipped in the 2017 Model 3. Over time, the cost of the display has gone down 24%. We've been able to reduce the weight by 12%, and we've reduced the power by 33%.
Yep, cost declines everywhere you look. And just to be clear, Tesla's mission statement makes this pretty obvious. They will never stop driving costs down everywhere they can find a cost saving without sacrificing quality and performance, and they will take it. This unboxed manufacturing system will save loads of cost in actually producing vehicles. But within that, individual components can also come down in cost. Tesla can also engineer different ways of getting the same job done more efficiently. We saw the wiring systems, right? The evolution there, saving 17 kilograms of mass, which is heaps. Tesla's not one day just going to say, well, you know, the costs for our vehicles are low enough now. They're going to keep driving them down. And if they have price leadership, this is a big fucking problem for companies trying to compete against Tesla, either selling electric vehicles to consumers or providing autonomous rides in a Robotaxi. Tesla's going to have the lowest hardware cost, and they're not going to stop. And every time they can, they'll pass cost savings on and reduce their cost per mile to use their Robotaxis. The limiting factor here is going to be wait times. Tesla will make as many of these vehicles as they can, as fast as they can. And every time they have enough on roads to meet demand without crazy wait times, they can lower the cost a little bit. That's going to be the limiting factor. Will wait times remain under control? This is a big problem for other companies trying to offer Robotaxi rides once Tesla's scaled up production of their Cybercab, because they don't have this cost advantage. They don't have the vertical integration.
At the same time, we've increased the brightness of the display by 50% and improved the color accuracy. So this is one of our favorite things at Tesla, is to make a component cheaper and better. At Tesla, the drive to improve efficiency in the car is never ending. I think of it as like peeling a carrot. You just take a swipe at it, a little bit falls off, doesn't really make much of a difference. But if you just keep at it, over time it accumulates into a pretty significant improvement. One of the changes that we're looking to make right now is to change something that's been steady for the last 60 years, 12 volts. 12 volts has been, as I said, for 60 years. The demand for power in the car has been steadily increasing to the point where we now have to have pretty large wires to drive over 200 amps of current around the car, which increases the mass and cost. With Cybertruck and all future Tesla platforms, we will be moving to 48 volts.
And spoiler alert, Cybertruck did in fact feature the 48-volt architecture. Incredible stuff. Optimus will also. The real question I have is, when they say future vehicles, this was before Tesla decided to have this interim range of more affordable vehicles, implementing some of the modular manufacturing stuff. Obviously, the Cybercab is 48-volt. But will their interim, more affordable vehicles also be on 48-volt architecture? Because if they are, that's going to save a fuck ton of money. But they're going to need some incredible supply chain, because these are going to be very high-volume vehicles.
Did by a factor of 4. And since power loss in the harness is resistance times the square of the current, a 4x reduction in current leads to a 16x reduction in lost power while distributing energy in the car. That allows for smaller wires, smaller E-fuses, and smaller controllers. It also allows us to make those heat sinks smaller, or in many cases, remove it completely, all benefiting the car in terms of mass and weight. 48 volts is the future for low voltage design at Tesla, and likely the rest of the industry in due course.
We welcome and encourage other OEMs and the entire supplier network to join us on this evolution.
You bet.
And by the way, I think it was after this presentation, but Tesla literally sent a document to all of the automotive CEOs on the planet. I'm not kidding, by the way. They literally sent them a document. The essence of the document was, hey, fuck faces, here's how to do 48-volt architecture. We've done your homework for you. The whole industry should adopt this, so here's how to do it. I'm not kidding, by the way. This actually happened. I don't know what the title of the document was. Probably wasn't hey, fuck face, but that was the gist. Hey, fuck face, we've done the homework. You need to adopt 48-volt architecture. Here's how to do it.
The number of wires in the car is driven by the number of endpoints that need to be powered and controlled. In the past, centralized control has led for wires spanning the entire car. For Cybertruck design, we have moved to a local controller where the wire is connected to the nearest controller, and those controllers are connected over Ethernet. Wires are routed to the nearest controller where the data is converted into a network packet for transmission to the correct location in the car. To be effective, the network must be reliable, have low latency, and low jitter, and these are all attributes that we've been able to achieve with the current design. The design has eliminated most of the cross-car wires in Cybertruck, and with the next-gen platform, we're going to finish the job and eliminate all of them.
This consolidated vehicle network allows us also to make a whole lot more dynamic changes on the fly to how components in the vehicle talk to each other, rather than the traditional approach of separate CAN buses that are spread throughout the vehicle.
Yeah,
and fixed in hardware.
And one of the nice things is that you can see the entire vehicle through a single connection, which wasn't possible in the past for debug. For the next-gen platform, we're looking to optimize the controller design across the entire car and across all of the organizations, not just for a given subsystem. Simplifying the wire harness will enable automation. 48 volts will allow us to reduce the size, mass, and cost of the low-voltage system. And it's one of the key things to enabling us to scale production of the low-voltage systems for the Master Plan 3.
So there you go, in case you forgot. Now you remember. Everyone seems to have forgotten about this. And now that we know Tesla's producing some interim, slightly more affordable vehicles with some of the next-gen manufacturing techniques, which we know will allow them to produce them faster and cheaper from a smaller factory footprint, I remind everybody once again that those vehicles enter production a few months from now. Nobody is ready. Want more content? Early access? Bunch of perks? Click the links in the pinned comment. AG1 is awesome. I've been taking it daily now for more than 3 years. It's a great way to fill in nutritional gaps. It's packed full of vitamins, minerals, and whole food source nutrients, plus has prebiotics, probiotics, and adaptogens to improve gut health, regularity, and help your body handle stress. I'm always looking for an edge to help me feel and perform my best, which is why I haven't missed a day of AG1 for more than 3 years. Just try it and see how you feel. Click the link in the pinned comment or head to drinkag1.com/SMR and get yourself a free 1-year supply of vitamin D3 plus K2 and 5 travel packs. This is what viewers of the channel had to say after trying AG1. I feel like I have a lot more energy since I started on AG1. Just got my AG1 in the mail, legit feeling the effects after day 3. 3 months ago, I started AG1 and have been enjoying the evenness of alertness and energy that lasts the day. I just started the wife on it too. Are you convinced yet? I mean, hey, it's worth trying, right? Click the link in the pinned comment or head to drinkag1.com/SMR, or I can keep going. This viewer, after about a month on AG1, definitely a lack of fatigue in the afternoon. Pleasant side effect is that my coffee intake has imploded and is almost down to 0. One more? Yeah, why not? I honestly feel younger and will be continuing to use AG1. This stuff really is crazy good. I didn't think it would be, but this stuff is awesome. It really is what everyone is saying. One more? Don't mind if I do. I've just received my 3rd month supply. I've drank it every day. I have so much energy throughout most of the day. I'm productive, started a new business, started socializing, refurbished a boat. It's no coincidence. Thank you for your persistence, your integrity, and your insights. Now look, these are not my words. These are not my testimonials. This is what you guys and girls are saying. Maybe it's 100% placebo effect. But even if that's the case, I think it's money well spent. Click the link in the pinned comment or head to drinkag1.com/SMR and get yourself a free 1-year supply of vitamin D3 plus K2 and 5 travel packs.